continue. Scotty Howell is the Vice President and General Manager of Robinson Iron and guides the day-to-day operation of the firm and the assessment of conditions to the removal, engineering, and installation of restored materials. Scotty launched Robinson Iron in 1975 as a spin-off of the Robinson Foundry, Inc. A graduate in engineering from Georgia Institute of Technology, Scotty holds a master's in business administration from the University of Chicago and is part owner of Robinson Iron. He learned the foundryman's craft from the bottom up so that he could be familiar with the requirements of each demanding job. Over the past 33 years, his resume of distinguished projects has included such iconic landmarks as the Raffles Hotel in Singapore, the White House in Washington, D.C., Vulcan in Birmingham, Alabama, and others too numerous to mention. Scotty.
Good morning. It's a pleasure to be here with you today. First things first, I would like to introduce this is my wife, Howell. Pat, take that, there's nothing on me. Danny's going to be demonstrating laser scanning using our handy scan, laser scan on the campus, the Pathfinder campus team. So we've already had position targets on it. And she will be creating a model for the while the certification is going on. How do I advance it? Okay.
That should advance it.
This one? Uh-oh. Need you back. There we go.
Yeah. There's a gap in there.
So which one? This one?
Just the 4 arrows.
This one? Okay. So I'd like to talk with you today about pattern making. For most all foundermen, the pattern is the beginning of the process. And everyone pretty much knows that the casting that you make can never be better than the pattern you used to make it with. Something is always lost in the process. So the pattern making part is crucial to pattern makers. And this goes way back to the late 19th century. And you can see from this woodcut from Badger's Foundry, the molding going on in the lower portion of the foundry operation. So the process has not really changed much in terms of the sand molding process. This is an early image taken from the Robinson Foundry floor in 1975. And the gentleman on the far left in the pork pie hat, whose name was Mr. Aubrey Brown, was my pattern maker. And Mr. Aubrey carved most of his patterns with a pocket knife. He was an amazing man, but he was 70 years old at this point in time, and there was no one behind him to take up the craft. So I knew I was going to be in trouble pretty quickly unless I did something to preserve the pattern making craft. So what I did was I managed to apprentice some people to Mr. Aubrey, and those people learned the pattern making craft, starting off with just wood and so forth. Now, how do you begin the pattern making process? Well, in many cases, you'll start with a drawing or a sketch. That drawing and sketch then would be carved into wood, like these very old wood patterns in our storage. And I see that we don't really do a good job of our housekeeping, but these are original wood patterns from the 19th century. And how do you do that? Well, originally we just carved them by hand. We used hand chisels and white pine, sometimes mahogany, and we made our patterns by hand, by carving. This is an image of some 19th century wood patterns, also carved by hand, on the wall in my office. Later, foundries began to make patterns out of wood, out of metal, because the wood didn't last very long. It got burned up in the process, so they began making metal patterns like these. These are loose metal patterns, again, quite old. Many of these date into the 1860s and 1870s. And later, they developed metal patterns that would be mounted to boards like this. These were called match plates. It was in about the late 80s and early 90s that we began to introduce plastics into the world of pattern making. And we used hard plastics, urethane-based, to create our patterns. We found this to be very efficient to make urethane-based patterns like this collar here without loss of detail. And also the urethane patterns were less expensive than the metal patterns. It's used by the creation of a mold, and then you pour the positive, which a pattern is always the positive, and the mold is the negative. And we used, again, would mount plastics to wood boards like these. And just for a very brief moment, I'd like to talk about the parting line, which is a very crucial part of a pattern. There are a couple of things that are very important about pattern making. One is the parting line is the point at which the pattern is separated. The halves of the mold are separated. It has to be clean. And you can see how the parting line is established here on this particular type of pattern. Also, the shrinkage factor is very important because iron shrinks and all metals shrink as they're poured into a mold. And this is a shot of a typical, what is called green sand mold, and I don't know why they call it green sand because it's definitely black. And it gets its black color because it's recycled in the foundry over and over, and the sand is burned. But that's the two halves of the mold. The upper half is called the cope, and the lower half is called the drag. And then, of course, molten iron would be poured into the void created by the pattern. The pattern is compressed in sand. Two halves of the mold separated, pattern is removed, leaving a hollow cavity into which the molten metal is poured. And you can see the parting line is, again, a very important part of the casting work, and it creates what we call plus metal, which has to be ground away. As I mentioned, the shrinkage is important, and foundrymen, pattern makers tend to use a lot of instruments such as oversized rulers so that they make their patterns bigger than they need to be. Iron shrinks 1/8 of an inch per linear foot. Other metals shrink at different rates. So the pattern has to be bigger. And then, of course, there are lots of quality considerations, and the development of the pattern is very important because, again, the casting that you make can never be better than the pattern used to create it with. And also, if the pattern and the gating is not set up properly, you can have casting flaws. And there are lots of ways to go wrong in a foundry. This happens to be a crack in the casting created by stress in the mold. So what we really want are nice, clean, detailed castings. And again, the pattern is crucial to that. Then we have a lot of coordination issues. The sizes of the pattern is, with creation of a flask. In this case, it's a wood box, which you would use an air set type sand. This is an ancient flask, and yes, that is kudzu. We have that in Alabama, lots of it. Again, an old style steel flask with trunnions, just a very large one with a large cope and a large drag. The gating is very important. This is the way the metal flows into the casting. In this case, you have a very large, what's called a riser, feeding that little finial there. The riser acts as a way for the metal to shrink as it flows into the casting, so that there would be no voids created inside the casting. Again, a gating system here shown so that you have the down sprue and then the feeders going into the hollow cavity created by the pattern. Small rosettes. And this is a multiple type pattern where 6 rosettes would be made per mold. Again, a down sprue, feeder, the little gates or runners feeding the two larger rosettes. So this brings me it's kind of a speedy way of getting me into the topic at hand, and that is the use of laser scanning for pattern making. And this is, we think, is our next step. We do have a scanner. The scanner that we use is small enough to go in an overhead bin on an airplane, so it travels very well. We can scan objects, and we're scanning this same leaf today, just as you've seen it, and create a model. And the great thing about the model making is that with the press of a button, we can account for shrinkage. So that's no longer a big concern of us. We can also take the scanner, we can go to sensitive properties. Let's say it's the U.S. Treasury building in Washington, where they don't want messy molds being prepared on site, and they don't want to give up their ironwork to be replicated. We can scan it on site, bring the model back to Alabama, and then we can create the patterns. Once we have the model scanned, we can manipulate it using a program called Creoform. And once we have the model exactly like we want it, the right size, we can then convert it to Mastercam and then use the Mastercam models to actually cut them in using a three-dimensional router. We have a Haas 3D router with a 5-foot by 10-foot table that we would cut, in this case, into a material called wren shape, which is tooling board. Once we cut this individual shape like this in the router, we can then take that, prepare a mold, and then develop the pattern. This is the router cutting a pair of patterns. This is a fluted shaft. I think you'll see in a moment something happening with this particular pattern. Being cut, this was cut in the wren shape. Since this is a deep fluted shaft, we would create the side flutes using a side core, what we call a wing core, on the outside of the pattern. That's our core box that creates the deep fluting on the outside of this particular lamp post. And we're getting pretty close to taking this to the foundry to be poured. And there we have a complete casting. This happens to be in aluminum. It's for a courthouse in Houston, Texas, called Harris County. And there we have the completed lamp post, and it will have a round globe on top of it in cast aluminum, all made with routed patterns. And then how much does all that cost? Well, since we own our own equipment and the materials themselves are not that expensive, it's not as expensive as, say, sending pattern makers to a job site and pulling molds and that sort of thing. So actually we see it as a cost saving for us, and also it is a much more efficient process, meaning I have the scanning and 3D routing turning out patterns faster than a crew of men can get set up and taken to a foundry. So in terms of the way it's affected us, it's been a very positive thing. So that's my talk for today. I'll be around all morning, and so will Jane. And if you'd like to see more of the equipment, we'd be glad to show you. So thank you very much.